Hello, class, and welcome to Section 6. Now we're going to talk about segment relationships inside of a circle. So your I will statement is going to say, I will use segment relationships to solve for missing segments inside of our circle. And today we're going to write on a flat book. So you should have received a whole piece of paper in class, and if your teacher did not assemble it with you or you were absent, just take that piece of paper, tear it in half, and I will assemble it with you. So once you have it in half, we're going to fold a flat book kind of like we did for 11.5's notes, only these aren't pre-printed. So just leave yourself a little space, then turn it over and press down. And now you'll have a situation where you have some tabs, and that's what we're going to write. So remember, at any time, things I've already written down, so you can push pause and go ahead and add them to your booklet. So let me just focus it in a little bit, and you can see what we're working with. So this is Chapter 11, Section 6. We're almost done. Last chapter. And we're going to be talking about segment relationships. So remember, line segments in circles are the chords. We have secants, and we're going to have tangents. So if you want to push pause, these are the titles on each of my little tabs, and then I will actually even write on the inside of my comp book. All right, so before I get started, also if you want to draw yourself some circles, I'm going to have 2 circles on each flap. So I'm going to have one on the upper part of the flap, this piece, and I'm going to have one on the base. So this one on the base is going to be our definition, and then the one on the top side over here is going to be my example. So I'm always going to start down here on the bottom. All right, so let's get started. First thing we're going to talk about is 2 chords. When I have 2 chords in a circle, and remember, a chord goes from the edge to the edge. It can be a diameter, but remember, not all chords are diameters. And then anytime they intersect each other, we will have 4 pieces. So I labeled them B, C, D, and E. And then there's a relationship happening and a proportion being set up. So just using the letters I have, I'm going to start it out. B times C is going to be equal to D times E. All right, make sure you're not adding them. Those added up aren't going to be the same, but when I multiply. So B times C and D times E. So piece times piece is equal to a piece of the chord times a piece of the chord. All right, so let's see if we can solve one. I'm just going to move up here to the top of my flap. And here I have them. So piece 3 times 4 is going to be equal to 2 times x. Now you can solve out the math. 3 times 4 is 12, and then we need to divide, and x equals 6. So right here, this little piece should be 6 units long. However, these are feet, yards, inches. They're not degrees. They are in some kind of unit of measure. All right, so that's for a chord and a chord. Our next little tab is what happens when I have 2 secants. So a lot of the pictures are drawn where they stop at the circle, and I drew one that continued on. Because remember, a secant is a line that continues on, and then we can talk about its chord like this. So I kind of drew it both ways. A lot of the book does this, but I wanted you to recognize this also. So how can we determine the line segments? This is different than saying B equals E. That's not going to be true in this case. That was only true when I had 2 tangents meeting. Then I had my segments that were equal to each other. But this is 2 secants. So here's how it's going to go. I'm going to have to be able to talk about my external piece of the secant. External meaning outside. So there's my external secant segment versus, that's right, my internal. So internal being inside the circle. So external, outside, internal being inside. All right, so I'm going to think of this as whole secant times the outside piece. So how would I get the whole secant? That's going to be b plus c times my outside piece. And that's going to be equal to the other secant in the same way. So the whole secant is e plus d times the outside piece. So I shortcut it for myself. I say whole secant times the outside equals the whole secant times the outside. All right, we don't get to count this little piece because it goes on forever. So we're only talking about where the two secants intersect. Here's their point of intersection versus the parts where they hit on the circle. So let's see this in action. Remember, you can push pause anytime you need to pause and slow it down, rewind it. All right, two secants, and I want to know the value of x. So first of all, I need the whole secant, so 9 plus 18 times the external piece. And that's going to be equal to this whole secant, 10 plus x, make sure you don't multiply, times its external piece. And now from here, it's just some algebra. So I will have to add up 9 plus 18 and then multiply it times 9. So 27 times 9 equals 100 plus 10x. So I'm just going to do a little distribute, and then I can solve for x. All right, so I can't wait to see what you have in class. All right, and then the last one we're going to work about is what happens if I have a secant and a tangent. Well, same type situation. I need the whole times the outside, and this whole piece times its outside piece. So that's really just going to be d times d, or I can shortcut that to d squared. That works on the tangent. So I'm going to set up a problem for you, and then you're going to get to solve it, and then we'll solve one in class together. So whole secant times the external equals the tangent squared. So here's the setup. Now you have two problems to solve on your own, and then we'll make sure we add a problem when you get to class, and I can't wait to see what you have discovered. All right, and I hope you have a great evening.